Hello and welcome to another Ben Code Swift tutorial in the series. Today we're going to be talking about protocols, how to declare them, what they are, what they do, etc., etc. So the first thing you're going to want to know is sort of what a protocol is. And basically, as Apple defines it, a protocol is a blueprint of methods, properties, functions, and other requirements that suit a particular task or a piece of functionality. Once you have a protocol created, they're then imported or linked to classes which, once linked, must conform to the protocols or conform to the blueprints. Protocols, however, contain no implementation of these functions or properties. In other words, protocols specify the base requirements of what a particular class must do. However, they themselves do not declare how it must do it. Now, you might say, this sort of reminds me of using a superclass and having subclasses, so inherit that superclass. However, what we're going to want to think about is polymorphism here, and that is why when you're coding in Swift or coding in any language where you can use protocols versus inheritance structures and things like that, you always would rather want to jump to protocols before you jump to inherit some sort of inheritance hierarchy, especially Swift when you already have a storyboarded view controller hierarchy and things like that. And you'll notice I'm doing this all on a playground just to make it a little bit easier for us to test things out. So the first thing you're going to want to know is that I started off by creating a protocol called vehicle. And the reason I did, I thought it was a good example of how I can use a protocol in place of inheritance structures. So as you can see, I declare a protocol just by typing protocol vehicle. Then I got my curly braces in which I'm going to declare what sort of things that I want each class that inherits the vehicle protocol to have. One of the things I'm going to create is a var of capacity that's an integer. And you'll notice after the integer that I have get in curly braces. And what that means is by using the get parameter here is I'm specifying that when I implement capacity in my class, it's going to have it does not have to be writable. If I used get set as I did in passengers, it does have to be writable. In other words, as you can see down in capacity, once I build a car, capacity doesn't change. I used get because I want to be able to use a constant here, which means that I cannot change 6 once it's created. However, because I use get set in passengers, it's I can't use a constant because get set means that it needs to be able to change. Passengers, obviously, there's not always 4 people in cars. Sometimes it might be 3, sometimes it might be 2, etc., etc., which means I need to be able to change it. Capacity is fixed. So if you see I try and if I'll put let here to try and make it a constant, it's going to fail because get set says that I have to make it a variable. There you go. So that's what those do. Pretty simple. The reason you have to use get set and not create a let here is because when you create a constant, you have to declare the value of it. But because you can't use any sort of implementation in a protocol, you can't declare a constant. It's just not possible because you can't implement it. That's why they created get and get set to be able to work around that issue. So then below, I'm going to create a class called car, and it's going to implement the vehicle protocol, which means when I do that, it has to implement these in whichever way it wants to, but they have to be implemented to this this specification, which means I have to create a variable called capacity. It doesn't have to be writable; all it has to be is readable, and that's what it is here. It has to create a variable called passengers. It has to be readable, has to be writable. That's why it's a variable here. And then I just set it to 4. And obviously the protocol doesn't care what I set it to, it just cares that it's there. I created a function that was empty as it is here, and then I created a function called getSpeed that returns an integer. In this one it returns 30 for a car. As you can see, the airplane, it returns 400, and the capacity and passengers are obviously vastly different. Hence why you use a protocol, you don't have to recreate everything, you know that everything that implements vehicles is going to have the same basic parameters, you can do the same functions with it, and so on, and so on, and so on. So that's basically all that protocols are. It's pretty, it honestly is as simple as it seems. And you might be like, okay, why? I'm just going to use inheritance. Well, don't. Use protocols if you can first. And especially because you're going to want to get familiar with using protocols because they really come in handy when you get in certain things. For instance, one thing if you start thinking about, the flow of your iOS app, let's say you have a table view list of items, right? Do I have something open here? So let's say I create a table view list of items in my view controller. I'm just going to size this to an iPhone just to make it easier for the video. As you see here, and I'm going to throw a table view controller in. Oops. Wow, that was weird. I'm going to grab a table view, and I'm just going to throw one right in. And it's going to have big content in it. Got a bunch of prototype cells, which obviously aren't real, but I can type things into them. You know, these are just whatever, just to sort of separate the cells individually and so on. So let's say you have a table view, right? And let's say you want your table view to be able to go to a view, right? So when you click the cell of a table view, it opens up a brand new view. And that's very common. That's very common, so obviously you want, you know, and so on and so on. We're going to go in Exist, we're going to go selection seg, and we're going to present modally, just for now. And so, let's say in this function, let's say, or not function, let's say in this view, you have 2 buttons. Oops. You've got a button 1, and button 2. And what the class wants to be able to do is it wants to be able to tell whether or not you press button 1 or button 2. And as you know, it seems easy enough. Okay, just button 1 or button 2, right? I'll just create an IB action for button 1, I'll create an IB action for button 2, and that's it. But then you need to start thinking of, okay, whoa. Okay, so I got, you know, I can detect when button 1 is pressed, but how do I actually send the information back, right? How do you send something up the chain of, you know, for lack of a better word, the chain of hierarchy? And if you think about doing it as an inherent instruction, you can't send something to a superclass. It doesn't work that way, but you can send things back and forth. If, you know, this can work with this one if it knows that it incorporates its protocol. And these are where this is where delegation comes in. So I'm going to leave this video offer here to make sure that it's not getting too long, that, you know, we don't have one super long video. And we're going to sort of pick it up with delegation in our next video, and how delegation plays into protocols and so on and so on. So thank you. I hope you found this informative, and I hope to see you in the next one.